Testing 1, 2, 3. Alright, I think we are live. How's it going, everyone? Thank you for tuning in with me on another Advent of Cyber stream. And it's day 9 already? Day 9 now? I mean, first it's hard to believe it's been a week, let alone a week and a day. Damn. Anyways, how's everyone doing tonight? Hope you all are doing alright. We're just going to try to have a chillax time doing TryHackMe things. And then also we're going to do some other stuff as well. I haven't decided what. Let me see what we're doing today. Alright, so we'll just need to use a VPN for this one. Alright. We'll have to use OpenVPN for this, so sorry I'm running a little late. It's been a long day. But hopefully I'll be able to get my mind off how long this day's been. Alright. Also, I forgot to close this. There we go. Alright, so we're doing day 9, and it's looking like we're doing some malware analysis, which sounds like fun. We're gonna have a little bit of fun doing some malware analysis, and around 8:30 we'll do whatever. We'll do whatever else we want to do, I guess. Maybe Fortnite, maybe GTA. I haven't decided yet. But anyway, guys, we may or may not have an after hours stream. It just depends on everything. It just depends on the stream, I guess. So yeah. Alright, so I'll be popping into the Hackers Hackin' stream VC. If anybody wants to hang out with me in there, you're more than welcome to. Alright, so I guess we'll start out with the story. Mainly because we don't have anything else or anyone else in here right now. And we're kind of running low on time before the other... we're kind of running late, so we'll just go straight to it. We'll go straight to the story. It says, She sells sharp shells by the sea-to shore. Okay. So here's the story so far. Having retrieved the deleted version of the malware that allows Tracy McGreedy to control elves remotely. Forensic McBlue and his team have started investigating to stop the mind control incident. They are now plotting to take revenge by analyzing the C2's backend infrastructure based on the malware's source code. So in this task, we're going to focus on the following vital learnings to assist Forensic McBlue in analyzing the retrieved malware sample. The foundations of analyzing malware samples safely, the fundamentals of .NET binaries, and the DNS spy tool for decompiling malware samples written in .NET, building an essential methodology for analyzing malware source code. Malware Handling 101. Warning: as handling a malware sample is dangerous. Always take precautions during your analysis. As mentioned, handling malware is dangerous because it is software explicitly designed to cause harm, steal information, or compromise the security and functionality of computer systems. Given this, we will again introduce the concept of malware sandboxing. A sandbox is like a pretend computer that acts like a real one. It is a safe place for experts to test malware and see how it behaves without any danger. Having a sandbox environment is essential when conducting malware analysis because it stops experts from running malware on their actual work computers, which could be risky and harmful. A typical environment setup of a malware sandbox contains the following. Network controls. Sandboxes often have network controls to limit and monitor the network traffic the malware generates. This also prevents propagation of malware in other assets. Virtualization. Many sandboxes use technologies like VMware, VirtualBox, or Hyper-V to run the malware in a controlled, isolated environment. This allows for easy snapshots, resets, and disposal after the analysis. Monitoring and logging. The sandboxes record the sandboxes record detailed logs of the malware's activities, including system interactions, network traffic, and system modification. These logs are invaluable for analyzing and understanding the malware's behavior. So we're going to review the connection card again and see what we need. So do we need to start the attack box today? No. Do we need to start the VM today? Yes, we do. We click this fucking trackpad. We start the machine here. Is there a split screen available? There is, but it's not showing up. Is there a direct link? Nope. Are we giving credentials to connect to it directly? Yes, we are. And it's not gonna matter whether we do a split view or RDP because we're going to use RDP. I'm sorry. It doesn't matter if we have the split view open or not. We're going to use RDP, which is my preferred method. Once we connect to it, we'll start following everything. TryHackMe, and give me the damn IP address. Give me the IP address. Come on. Thank you. Thank you. Alright, so we just take this shit. We just take this credentials here. I forgot to save it, didn't I? Oh, no, I didn't. I'm gonna shut my damn phone off, though. Shut my phone off, come on. There we go. Alright. Over here. Alrighty. So we started the machine and we're connecting to it through RDP. So, and like the last Advent of Cyber day yesterday, the VM has all the artifacts and clues to uncover McGreedy's shady plan. There's no need for his fancy hacks, brute force, and the like. Dive into FTK Imager and start the detective work. Wait a minute. Didn't we do this? Oh, I clicked the wrong thing. I clicked the wrong thing. Ah, bloody hell. I clicked the wrong thing. That explains it. That explains it. Dang it. You get that, I had a long day. I had a long day. Okay, we're doing this again. Alright, so we're going to try this again. Edit. It's kind of like, okay. Optional, of course, building from the VM. On day 8, you can use this password right here. Day 9. To unlock the zip archive and access the malicious save and connect. Malicious sample for today's decompilation exercise. However, for your convenience, the VM on this task will have the defanged malware sample placed in the artifacts folder on the desktop. Check the Intro to Malware Analysis room as a refresher for static analysis concepts. .NET binaries are compiled files containing code written in languages compatible with the .NET framework, such as C#, VB.NET, F#, or the managed C++. These binaries are executable files with the .exe extension, or dynamic link libraries, or DLLs with the .dll extension. They can also be assemblies that contain the multiple file types and resources. Compared to the other programming languages like C or C++, languages that use .NET, such as C#, don't directly translate the code into machine code after compilation. Instead, they use an intermediate language, IL, like a pseudocode, and translate it into the native machine code during runtime via Common Language Runtime Environment, or CLR. This may be a bit overwhelming. In simple terms, it's only possible to analyze a C or C++ compiled binary by reading its assembly instructions low level. Meanwhile, a C# binary can be decompiled and its source code retrieved, since the intermediate language contains metadata which can be reconverted to its source code form. And I'm not that familiar with C#. Based on the ELB's initial checks, it's been discovered that the retrieved malware is written in C#. So let's quickly discuss C#'s code syntax to analyze the sample effectively. So you can skip this section if you're already familiar with C#, or else click the view code snippets below. So for this section, we have namespaces, classes, functions, and variables. For the section, let's use this code snippet right here. I'll just open all of these tabs. Alright, so a namespace right here is a container that organizes related code elements such as classes into a logical grouping. It helps prevent naming conflicts and provides structure to the code. In this example, the namespace demo only is the namespace that contains the basic programming class. What's a class? The class defines the structure and behavior through functions or methods of the objects it contains. In this example, basic programming is a class that includes the main function, and the show output function. Moreover, the main function is the program's entry point, where this program starts its execution. A function is basically a reusable block of code that performs a specific task or action. In this example, the show output function right here takes a string through the text argument as an input and uses it on console.writeLine to print it as its output. Note that showOutput function only receives one argument based on how it is written. And variable is a named storage location that can hold data such as numbers or integers, text or strings, or objects. In this example, to print, to_print, right here, is a variable that handles the text "Hello world." For loops, a for loop is a control structure used to repeatedly execute a block of code for a specified number of times. It typically consists of three main components: initialization, condition, and iteration. Let's use the example below. So let's copy this on over to here, I guess. Might need this later, but maybe not. So, in this example, the loop is initialized with 1, the integer 1, and is stored in the variable I, or underscore, not underscore, lowercase I, for initialization. Checks if the variable I is less than or equal to 5, the condition, integer 5 of course, and increments 1 to itself, adds 1 to itself, every loop iteration. So in simple terms, the code snippet means that it will call the console.writeLine function 5 times, since the loop will count from 1 to 5, and loops can be immediately terminated using the code break. Conditional statements like if and else are control flow statements used for conditional code execution. They allow you to control which code block should be executed based on the specified condition. So, based on the example above, like here, if the if statement checks whether the number variable contains a number greater than 5 and prints a string. The number is greater than 5. If that condition is not satisfied, it will go to the else statement, which prints the number is less than or equal to 5. Essentially, it will go to the code block of the if statement if the number variable is 7, and it will go to the else code block if the number variable is set to 4. And for importing modules, so C# uses the using directive to include namespaces and access classes and functions from external libraries. The code snippet above loads an external namespace called system. This means that this code can now use everything inside the system namespace. Don't worry if you find these code snippets a little overwhelming. Once we start analyzing the malware, the following sections will be much easier to understand. According to Forensic McBlue, the retrieved malware sample is presumed to be related to the organization's remote mind control over C2 incident. So, to build the right mindset in solving this case, let's look at the run-through below about malware and C2 capabilities. C2, or command and control, refers to a centralized system or infrastructure that malicious actors use to remotely manage compromised devices or systems. It serves as a channel through which attackers issue commands to compromised entities, enabling them to carry out various activities such as data theft, surveillance, or further malware propagation. So we got C2 connection diagram. So the user executes the malware connects to the C2 server and asks for instructions, in which it responds with a set of instructions. The malware executes the instructions retrieved from the C2 server. The malware reports back the output. C2 and the attacker connects to the C2 server and issues commands to be executed onto the victim machine. Seeing C2 traffic means that malware has already been executed inside the victim machine. As detailed in diagram above, in terms of cyber kill chain stages, the attacker has successfully crafted and delivered the malware to the target and potentially moves laterally inside the network to achieve its objectives. To expound further, malware with C2 capabilities typically exhibits the following behaviors. HTTP requests. C2 servers often communicate with compromised assets and using HTTP or HTTPS requests. These requests can be used to send commands or retrieve data. Command execution is the most common, allowing attackers to execute OS commands inside the machine. Sleep or delay. To evade detection and maintain stealth, the threat actors typically instruct the running malware to enter a sleep or delay for a specific period. During this time, the malware won't do anything. It will only connect back to the C2 server once the timer completes. we will try to find these functionalities in the following section. Now that we've tackled the theoretical concepts to build our technical skills, let's start playing with fire or malware. Since we already assume that the malware sample is written in C#, we will use DNS Spy to compile the binary and review its source code. DNS Spy is an open source .NET assembly debugger and editor. It is typically used in a user-friendly, interactive way. It's also capable of modifying the retrieved's source code or editing, setting breakpoints, or running through the code one step at a time, debugging. As mentioned before, we won't execute the malware, so the debugging functionality will not be discussed in the following sections. To proceed, let's go to the virtual machine and start the DNS Spy tool by double-clicking the shortcut. We're gonna double-click the shortcut on the desktop. So let's double-click on this. Right, so it's loading now. Oh, I accidentally opened it twice. Alright. Once the tool is open, we will load the malware sample by navigating to File Open, located on the upper left side of the application. It's also starting to rain, so when we get to the prompt, we'll click the following to navigate to the malware's location. This PC, desktop artifacts. Okay, let's go. Artifacts. Now that you are inside the malware sample folder, you need to change the file type to all files to see the defined version of the binary. Next, double click the malware sample to load it into the application. Alright. Once the malware sample is loaded, you'll have a view like the image below. The next step is to click the main string, which will take you to the entry point of the application. As discussed in the previous section, the main function is a class in the program's entry point. This means that once the application is executed, the line of code inside that function will be run one step at a time until the end of the code block. However, we won't be dealing with this function yet, since reviewing it without understanding the other functions embedded in the malware sample can be a bit confusing. You may have been a little overwhelmed when you saw the main function, but don't worry. We'll discuss the other functions before building this malware execution pipeline. Focusing on the individual functions before dealing with the main function can be considered a modular approach. Doing this allows us to break down the malware's functionalities without getting bogged down with long code snippets. Moreover, it allows us to recognize some potential execution patterns that ease our overall understanding of the malware. Start with view the list of functions inside the program class by clicking on the highlighted section, as shown in the image below. Okay. Here. After clicking, you will see functions in the drop-down menu. And let's run through them individually to better understand each code's meaning. You can click on the items as we discuss them to compare the code in DNS5. It's also advisable to read the .NET framework documentation. I'll read this later. Don't worry, I'm favoriting it to read. To learn more about the internal functions as mentioned in the following sections. Get it. Based on the source code, the getIt function uses the web request line, not web request class from the system.net namespace. And is initialized by the function's URL argument. Name is a dead giveaway that the web request is being used to initiate an HTTP request from a remote URL. You can render the namespace details by hovering over the web request string, similar to what you see in the image above, right here. So, clicking it, by the default, the HTTP method set to the web request class is get. This means that we can assume that the HTTP request made by this function is a get request. 3 lines of code inside the function can be expanded by the comments written for every line. In other words, the getIt function accepts a URL as its argument, configures the parameters needed for the HTTP GET request, and returns the value of the response. Post it. Like the getIt function, the posted function also uses the web request class. However, you might observe that it has configured more properties than the first one. The most notable is the method property, wherein the value is set to post. This means that the HTTP request made by this function is a post request. It submits the second argument as its post data. Notable lines are annotated with the post snippet below, so you can see what we have right here. In other words, actually, in simple terms, the posted function accepts an additional argument as its post data, which is then submitted to the target URL and returns the response it received. The sleeper function only contains a single line, a call to the thread.sleep function. The thread.sleep function accepts an integer as its argument and makes the program pause for milliseconds based on the value passed to it. So there's the lines right there. Accepts one argument. Sets milliseconds. The usage of the thread.sleep function is typical behavior malware uses to pause its execution to evade detection. Execute command. Given the namespace and class name, system.diagnosis.process of the initialized process class, the first code line, it seems that this function is being used to spawn a process. According to the Microsoft documentation, from the initialization of the process start info properties, we can also see that this file, the file to be executed is command.exe, and that the execute command's argument command variable is being passed as a process argument. In short, the code snippet results to command.exe/c commands underscore variable. You can also see that here in this command snippet. Another thing to note is that the WindowsSile property is set to process.windowsile.hidden. This means that the process will run without a window. As such, it's a way to hide the malware's malicious command execution. This function serves as the malware's OS command execution function. Note we won't be diving deeper into cryptography, so we will skip discussing the imported functions used to encrypt. So the giveaways in this function are the AES classes used in the middle of the code block. If you hover over the AES managed variable, it also shows the namespace system.security.cryptography, which somehow means that everything here is related to cryptography or encryption. Moreover, the encryptor function accepts an argument and encrypts it using the hard-coded key and IV values. And lastly, it encodes the encrypted bytes into base 64 using the convert.toBase64 string function. In summary, the function encrypts a plaintext string using AES cipher together with the key and IV values, and returns the encoded base 64 value of the encrypted version of the string. Note, we won't be diving deeper into cryptography. So we're skipping the imported functions used to crypt. The function is the opposite of the encryptor function, decryptor, which expects a base 64 string, decodes it, and proceeds to the decryption to retrieve the plaintext string. Implant. The last function is the implant function. It accepts a URL string as its argument, initiates an HTTP request to the URL argument, and decodes it with base 64. It also retrieves the app data path and attempts to write the contents of the base 64 encoded file into a file. Lastly, if the implanted file was written successfully, it returns its location. If not, it returns an empty string. In the context of malware functions, the implant function is a dropper function. This means it downloads and stores other malware inside the compromised machine. Now that we have analyzed the other functions in the malware sample, we will return to the main function to complete the malware's execution pipeline. So we haven't fully analyzed it, but let's have a look at all this. Obviously we see a key, we see command, executed, paths, all of that stuff. We'll be having a look at all of these, we'll be answering all of these questions in a bit. So now that we've analyzed the other functions in the malware sample, we will return to the main function to complete the malware execution's pipeline. Again, viewing the main function's source code is a bit overwhelming since its code block contains over 60 lines. To make things simple, let's split the analysis into 3. Code executed before the loop, which is right here. So the first code for the loop executes these, which is self-explanatory in the comments right here. which you can see. As you can see, most of these lines in this section are about initializing values in a variable. However, there are two notable function calls made. The call to the DNS.getHostName function that retrieves the victim machine's host name. The attempt to distinguish the compromised machines based on their host name is typical malware behavior. And we have already discussed the post-it function, and we know that it makes the post request to the URL first argument, and then submits the host name as its post data, the second argument. In the initial step, it seems that the malware reports the host name of the compromised machine first to establish the C2 connection before executing the other functionalities. Code inside the for loop before the code block of the if statement. In this section, you'll see that the for loop is written without any initialized values on the initialization, condition, and increment for parentheses. Semicolon, not semicolon, parentheses. For this means that the loop will run indefinitely until a break statement is used. Afterwards, the first line inside the loop block uses the sleeper function, wherein the count variable is being passed. Remember that this variable was already initialized before the for loop statement. The following code lines are variable initialization, wherein the str and str2 variables are used, e.g. if the value of str or string is http able.com and the value is of string 2 is test, the resulting value for the URL2 variable is http evil.com/tasks/test, all uppercase. Test being all uppercase. So eventually the URL2 variable is used by the getIt function to do a get request to the past URL, and the result is stored in the it variable. Lastly, the execution flow will enter the if statement only if the it variable is not empty. You may view the detailed annotations in the code snippet below. So here it is. If you want to have a look, I'm going to copy it myself. I'm going to copy it and put it in my notes. In summary, this section is focused on the preparation of the variables to execute the HTTP GET request to the tasks endpoint and enters the if statement code block once the condition is satisfied. Code executed within the first if statement. Continuing the code, the execution flow, this code block will only be reached if the GET request on the task's endpoint contains a value. the section before the if, parentheses, exclamation point, this if statement right here is focused on initializing variables A and text. It starts by decrypting the string stored on the it variable and splits it with a space character. Decryptor it parentheses it dot split, yeah, that variable, and the A variable's value is the first element of the resulting array, and the text variable combines all the elements in the same array, excluding the first element. The example of below shows how the it variable is processed. You can see right here. You want to have a read at that. If you want to have a read at that on the stream, I don't know if you can see it well. To simplify, the code snippet discussed above focuses on setting up the values of A and text variables, which will be used in succeeding conditional statements. Nested conditional statements. This next section focuses on the conditional statements based on the A variable's value. You might see that the conditions in the if statements are all set to not. This means that if the condition is satisfied, e.g. variable A is not equal to sleep, it will go inside the code block to assess it with another condition, e.g. check if variable A is not equal to shell. Otherwise, it will jump to its counterpart else statement. We can simplify this code with a pseudocode like this. If A equals sleep, then execute code. Code block. Else if A equals shell, then execute shell code block. So on and so on. Else if A implant equals implant, execute implant shell and implant. Execute implant shell code block. Else if A equals quit, then execute quit code block. You can follow the if-else pairing by clicking the if in the if statement line. Then the conditions of each conditional statement can be summarized in this table. So, sleep sets the value of the count variable, which is being used by the sleeper function. Shell uses the command execute command function to run OS commands with the text variable, encrypts the command execution output using the encryptor function, and reports the encrypted string to the C2 server using the post-it function via results endpoint. Implant executes the implant function with the redacted domain, encrypts the output of the implant function via the encryptor function, and reports the encrypted string to the C2 server using the post-it function via the results endpoint. And quit sets the flag variable to true. Remember that the A variable's value is based on the response received after making an HTTP request to the task's endpoint. This means every condition in this code block is based on the instructions pulled from that endpoint. Hence, it can be said that the task's URL is the endpoint used by the malware to pull C2 commands issued by the attacker. Moreover, all the implant and shell command responses are submitted as post requests via to the URL3 variable. Remember that this variable handles the results endpoint, all command execution and implant outputs are reported to the C2 using the results endpoint. This may be a bit overwhelming, so let's summarize key learnings regarding this code block. The A variable, which is dependent on the GET request made to the task's endpoint, contain the actual instruction pull from the C2 server. This seems to be the command and control functionality, wherein the malware's succeeding actions depend on the commands the attacker sets within the C2 server. The shell and implant command responses are submitted as a post request to the results endpoint. This seems to be the malware's reporting functionality, wherein it sends the results of its actions back to the C2 server. The instructions pulled from the C2 server are limited to the following: sleep, shell, implant, and quit. Last, breaking the loop. So lastly, the final conditional statement at the ends. If the flag variable is set to true, then if that statement is satisfied, it will execute a break statement. This means that if the if statement that contains the quit condition makes the infinite for loop stop. It just makes the quit condition makes the infinite for loop stop. So it terminates the malware execution flow. Congratulations, you have completed the malware sample analysis and discovered some notable C2 endpoints that can be used to take revenge on McReady. So let's answer some questions. And we'll do that, doing all of this again. So first we click this right now. We have the main stream. This gives us a URL, which we will then put in our answers. Not so secret anymore. That's right, that's HTTP, not HTTPS. What? Hold on. Okay. Let me just have a look here. Okay. Alright, so next we have a look here. Let's post it. Over here, so I'll answer with that. Analyze the malware again. See another URL. That would be here. This is encryptor, so we should see key. Base 64. And that's a key right here. We'll copy that. Okay, so what's next? So we have a look through here. Keep having a look. Got the key right there. We have a flag. We have this user agent, which we will copy over here. Look at the hint. I'm gonna look at the hint. We're still having a look at the malware. Of course, we can always get a refresher. So we're almost done with this. We'll probably start the other stream around 8:30 or so. What seconds is the hard-coded value used by a sleep function? Sleeper. Post it right here. Get it. Encryptor. Program quicker. Man. Let me see here. Not the best idea. Let me look at my notes here. Sleeper function. Okay. There's a sleeper function. Look for the sleeper function. It's hard-coded somewhere. Here's... Hello, Kami Hatsune. How's it going? No, times 1,000. Milliseconds. It's been there. It's been there. Okay. Milliseconds. Apparently. Today's been there. Ay, ay, ay. It's been a hell of a day. It's been a hell of a day. Bank account. Shut up, page 15. My brain. So, we just now finished the room, so I'll favorite these to read later. Alright, let's exit out of this. Close this connection. I'll save all of these, why not? I'll save all of these. What the hell? Okay, so we finish the room. I'm gonna shut this thing down. And move over here. Got up from a nap. Well, that's good at least. Alright. Add over. Well, at least the ads didn't at least the ads are done after I finish the hacker shit. Alright guys. I'm gonna exit from the Hackers Hacking VC. We're done for the day, guys. We're done for the day. And now, guess what we're doing? Guess what we're doing, guys? That's right. That's right. We're doing other stuff. So we're gonna stop the YouTube stream at 8:40. At 8:40, then we'll reset the stream. I think we'll just play some GTA today. I'm not really feeling Fortnite, but I'm feeling GTA. We're gonna fucking I'm not gonna say it. I'm not gonna say it on the TryHackMe stream. Alright guys, yeah, we'll still be on here on Twitch. We're just, yeah, we'll just do some GTA on Twitch and YouTube. We'll have a second. We're gonna have a second, we'll have a second YouTube stream set up here in a bit. I can't believe it took like an hour to finish this. I expected it to be done like maybe in 30 minutes. Maybe. So we'll do the rest of the stream playing GTA over on Twitch. We'll set up a second Twitch stream so I can stream GTA 5. And it'll be great fun. It'll be great fun. Alright. We don't have a lot of people for chat room shoutouts, so we'll just do a shout out to Kami Hatsune, I guess. Shout out Kami Hatsune. Do we have any Twitter shoutouts, by the way? Don't think we have Twitter shoutouts, which is fine. And I don't believe we have any Mastodon shoutouts, do we? We don't. Okay. Well, we're gonna get the GTA 5 stream started up on YouTube. I just need to get it all set up and everything. Get that stream, I'm gonna get this stream scheduled. So anyway, guys, how's everyone doing? How's everyone been doing today? You guys are doing well. And I think we might do we might do a we might do some after hours stuff. I've not decided yet. Who knows? Who knows? Anyways. I'm gonna take a quick little break. Fix your sleep schedule. That's fun. That's fun. Alright, it's 8:40. We're gonna reset stream on YouTube. Yeah, we'll go ahead and reset the stream on YouTube. And I'll be back here in about 5 minutes. Just so we have everything prepared. So yeah. Stay tuned, guys. We'll be playing some GTA Online here in a bit, so just hang on a bit. And if you're watching on the YouTube VOD, thank you for watching. If you're watching with the TryHackMe stuff, I'll be back on in about 5 minutes. In about 5 minutes or 4 minutes, if you're watching live. on YouTube. But if you're watching on Twitch, we're not going anywhere. We're just splitting the streams up in two. So, yeah. Anyway, guys, BRB real quick. Let's go ahead and turn off the YouTube stream, and everyone else, I'll turn on the BRB stream, screen. So, BRB, guys.